All right, everybody, we're going to do just one more example involving L'Hopital's rule, just a different way of looking at it. Today, I want to make sure you practice some of these using the second worksheet for L'Hopital's rule, and then make sure you find that link for the AP Classroom assignment for your daily task. So today, the type of problem we're looking at is they're asking you to find the value of a rational function as it goes to infinity or negative infinity or something like that. And then you're given a function and you're given another function's derivative. So if you look closely at this, we're given f of x and g prime of x, and we know that the limit as x goes to negative infinity of g of x is negative infinity. So that's kind of our big clue on how we are going to be able to use L'Hopital's rule. Now they're asking us to find the limit as x goes to negative infinity of f of x over g of x. So just trying to remember some properties of limits. If we have the limit as x goes to anything of a rational function or of a quotient like this, we can actually think of this as the limit as x goes to negative infinity of the top function over the limit as x goes to negative infinity of the bottom function. So that was just a property we learned from chapter 1 way back at the beginning of the year. All right. Now we don't know yet, we can find it, what the limit as x goes to negative infinity of f of x is, but they gave us the limit as x goes to negative infinity of g of x, which is negative infinity. So what we're going to do next is find the limit as x goes to negative infinity of f of x. So to do that, we would get, let's see, f of x is 4x plus 2e to the 3x. So if we were to substitute in negative infinity, you would get 4 times negative infinity plus 2 times e to the 3 times negative infinity. Okay, now this is just arbitrary. This isn't actually, we won't get a number out of this, but this 4 times negative infinity will just get you a really large negative number, so we'll just call that negative infinity. And then this 2e to the 3 times negative infinity actually is like saying 2e to a really large negative number, so it's kind of like saying 2 over e to the infinity. Now, e to the infinity is just going to keep getting bigger and bigger. So that's like saying infinity. So now we have negative infinity plus 2 over infinity. Well, this 2 over infinity, if you think way back to those shortcuts we learned, I think it was in chapter 3, 2 over infinity, any constant over infinity is going to equal 0. So this is just like saying this whole thing is negative infinity. So the limit as x goes to negative infinity of f of x is also negative infinity. So what we end up getting here is negative infinity over negative infinity, which is an indeterminate form. So that means we can use L'Hopital's rule. So that means the limit as x goes to negative infinity of f of x over g of x is going to be the same as the limit as x goes to negative infinity of f prime of x over g prime of x. Okay, so this setup that we did in red and blue helps us get to the fact that we can use L'Hopital's rule. So now what we have to do is just find f prime of x, because we already know g prime of x. So f prime of x is going to be 4 plus the derivative of e to the 3x is 3e to the 3x using the chain rule. So that's just going to be 6e to the 3x. And then g prime of x is 2 over x minus 3 secant squared of 4 over x. Just because of space, I'm going to continue this on the next page. All right, so we ended up with this limit right here. That's our f prime of x over g prime of x. So now if we do some direct substitution, technically we can't substitute negative infinity in, but we can think of it as really large numbers to help analyze how the function is reacting to that. So we would get 4 plus 6e to the 3 times negative infinity over 2 over negative infinity minus 3 secant squared of 4 over negative infinity. All right, so a couple of things happening here. On the top, we have 4 plus. Now remember, this e to the 3 times negative infinity is like saying 6 over e to the infinity over anything over an infinity is going to be 0. So this also becomes 3 secant squared of 0. Now remember, 6 over e to the infinity, that's kind of like saying 6 over infinity, which is basically like saying 0. So on the top, we get 4 plus 0 over negative 3 secant squared of 0 is going to be 1 over cosine squared of 0 using our reciprocal identities. So we get 4 over negative 3 times 1 over 1 squared. So this just ends up being negative 4/3. And since we didn't know what g of x was, what you could do is graph the function for f prime of x over g of x. And you should see as x goes to negative infinity, it appears that there's a horizontal asymptote at about negative 4/3. All right, so knowing that now, go ahead, click the link, get onto AP Classroom to do that daily task, and you can also use your second L'Hopital's worksheet to get a little extra practice.